All right, so what we're talking about today is, because we talked about similarity the last time, we talked about similar polygons, we talked about ratios and proportions, and so on and so forth. So we just kind of, again, ratios and proportions is something that should have been a little bit more like review, and then the similar polygons is kind of the new information. So I want you to recall the kind of some definitions that we've talked about in class so far. The first one being congruence. Right? Understanding that congruence, right, is meaning the exact same size and shape, which is why we can always put that equals kind of with congruence. In fact, even the symbol for congruence has the equal sign in it. Similarity is quite a bit different. Similarity means having the exact same shape, but not necessarily the same size. Okay? All right, and so some interesting things that you guys can think about it's kind of literally right there in the actual symbol. If you look at the congruent symbol, right, it's got the same thing as a similarity over an equal sign. So it's same size and shape, okay? Or same shape and size. With similarity, it's just the same shape. And you can think about the little tilde that kind of we use for it, just means S for shape, okay? So that means that all angles are, so if something is for us to be similar, right, it means that all angles are congruent and all sides are proportional. Please note that two objects can be congruent and similar, but they can't be similar and congruent. I mean, they can be, but not always, okay? So two shapes that are congruent are always also similar, right? But two similar shapes are not always congruent, okay? So just to kind of give you a little bit of taste of that, so this first theorem that we're going to talk about, because we're going to be focusing more on triangles today. All right, so this first theorem, not even a theorem, sorry, it's a postulate, which is angle-angle similarity. And what it says is that if two angles of one triangle are congruent to two angles of another triangle, then automatically those triangles are similar. So the cool thing with triangles is all I have to do is prove two angles are congruent in the triangles, and that automatically makes them similar. And you're probably wondering why. Don't worry, guys, I will come back to this, just to let you know. All right, so here I just have a little kind of a demonstration why. Okay, so I've got the top triangle has angle A at 39 degrees and B at 41. The bottom triangle has this angle D at 39 degrees and angle D at 41. Okay, so no matter what shape or size I make either of these triangles, or orientation, as long as those two angles stay the same, right? If you can see, I also have their ratios calculated up here. And you can see that all the ratios are the same. They all equal 1.28, 1.28, 1.28. Okay? And again, we're comparing AC to DE, and that gives us 1.8. CB to EF, which is 1.28, and AB to DF. Okay? So again, we're looking at the ratios between each sides, and this is what it means for them to be proportional. AC over DE equals 1.28, which also equals CB over EF, which equals 1.28, which also equals AB over DF. Okay? So when we say the sides are in proportion, that's what we're talking about. So it doesn't matter what size the size of the sides are, right? No matter how big I make or how crazy I orient these triangles, as long as those two angles are congruent. All right, watch what's happening every time I change it. What's going on with the ratios? No matter what size or shape I make this other triangle, right? The sides stay in proportion every single time. Okay? And again, the reason why I'm showing you this way is because you can't actually prove angle-angle similarity. You can just visualize it. And basically what it means is and if I try and move this guy up here. So if I move this guy to D or to A, try to move that right on it. That'll have to be good enough. I move it to B, right? No matter how big I make one of these sides, right, and how much longer I make one of the sides that's between them even, right, it's not going to change anything. Okay, they're still going to be proportional. Okay, I've included this if you kind of want to play around with this too on Canvas. Okay, but that's just kind of the explanation for angle-angle similarity and why it works. Okay. All right, so basically now what we have is a way of showing and knowing that two triangles are similar. Is if two of their angles are congruent, they're congruent, okay? But we have some more similarity theorems. Now these two are going to look very, very familiar, okay? Oop, whoa, sorry, I don't know why I did that. So the two theorems that we have are side, side, side similarity, right? And it doesn't really show it here, but what we use to kind of denote this, right, is we say side, 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 and then we use the similarity symbol after. Not to be confused with side, side, side congruence, which is just SSS, okay? And what this says is that if all of the ratios between my triangles, or in my triangles, if all the ratios between their corresponding sides are equal, so the sides are all proportional, right, then I've automatically got similar triangles, okay? Which is kind of nice because that also tells me that if all my sides are proportional, right, I'm guaranteed to have congruent angles. Okay? Then we have angle side similarity, which says that if two sides of a triangle are proportional, right, and then the angle in between, so the included angle, are congruent, so in this case S and Y, then those two triangles are guaranteed to be similar. Okay? That kind of makes sense.
So basically, you just can't prove they're equal in a way.
What do you mean?
I mean congruent. Like you can only prove that they're similar.
Right. Well, we can prove that they're similar, but we can't prove necessarily. Well, we can actually use these to prove that they're congruent. The thing is if these guys are congruent, then this ratio, for example, JK over MP, KL over PQ, LJ over QM, in order for them to be congruent, that ratio has to equal 1. Okay? But otherwise, right, as long as they're proportional, so whatever that scale factor is between them, right, that just proves that they're going to be similar no matter what. All right. So again, two different theorems. So we're going to do some proofs first, and then we'll do some algebra in just a minute to kind of go through these. Okay. So I'm going to move this up a little bit more. Again, you will have these available. And for this one, we also, for the symbol that we use for it, right, because not to be confused with the congruence statement that we had, we just add a little similarity symbol afterwards. Okay, so we have side, 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 and side angle side similarity. All right. So I have a couple of proofs here. We're going to do 6 and 7 first, and I apologize, this should be. Okay. So what we're going to do is we're going to basically, we're given a lot of the key steps of the proof, and then we want to go ahead and kind of complete this proof. So in the first one, we have ST over WV. So we have, and I'm going to use colors to kind of denote that. We have ST over WV equals TU over VX, which equals US over WX. Okay? So what we have here is all three sides proportional. Okay? So what's the very first thing we need to write whenever we're doing a proof? The given information. Okay? In this case, it's ST over WV is equal to TU over VX. Sorry, my U's and V's kind of look similar. And then US over XW. Now, my whole goal here is to prove the triangle STU, so STU, is similar to triangle WVX. Do we know that that's got to be true? Yeah, this is just literally the extension of, this is just one step proving, right? Those triangles are congruent, or sorry, similar, using side, side, side similarity. Okay, so triangle STU is similar to triangle WVX. Because again, we have all three sides proportional. Okay? All right, so for number 7, okay, again, I would always go through, and you can use different colors if you'd like while you're doing this. It usually helps me out as well. So I'm going to go AB over the ratio of AB over DE, right, is going to equal the ratio between BC over EF. It's going to be the ratio AC over DF. Okay? And again, that's our given information. So for this one, again, once we know that that ratio is true, and we can see that all 3 of our sides kind of match up here, right? It's very easy for us to go, okay, well, that's triangle ABC is going to be similar to triangle DEF. Okay? Just simply by side similarity. Okay? And again, from number 7, the only thing we're really missing in here is what? What do we need? What's the first thing we need to do when we're writing a proof? Given. Okay. So we're missing AB over DE equal to BC over EF, which is equal to AC over DF. Okay? Pretty simple proofs. Okay? One-step proofs. We're going to take it a little bit further now. Okay? So number 8, all that we're given, and I'll even highlight it, use the colors for you. All that we're given, right, is that GK is parallel to HJ. So I'll go ahead and just fill that in because I know that you guys already know that. Okay. Now we want to try and prove that these triangles are similar. Okay? Well, how might we do this? So it kind of tells us already that we're going to use corresponding angles. Okay, that's the nice thing about having parallel lines. So if we're going to use corresponding angles, which angles are we going to say are congruent or supplementary? What are we going to say here? Who can tell me? Anybody on Zoom want to speak up?
They're both congruent.
What's congruent? Which?
Wait, which one are we on? Are
We're
we on the top left?
We're on bottom left.
I knew it. Oh, okay. Give me a second. I need to figure this one out.
Okay. Okay. So he said that they're congruent. Well, that's right. We're going to have 2 congruent angles in here. Which ones are going to be congruent because they're corresponding angles? Yeah. GH and KJ. So those are sides, right? Those are segments. So we're trying to use corresponding angles. So let's look at our third step to kind of see what what our next clue is. Okay? They're saying that angle G is congruent to JHI. Well, that's this one and this one. Okay? But that's not what we're saying in step number 2. So what kind of angles are congruent in step number 2? Yes. J and K, so we can say angle K, that's fine. But remember, we can't call this angle J because this is angle J and that's also angle J. IJH, perfect. So she's saying these 2 angles are congruent. IJH. Perfect. By corresponding angles. Okay. Now our third step said angle G is congruent to angle JHI. Right? Why is that true? Why is that true? I'll give you guys a hint. You already know it.
Their corresponding angles.
They're corresponding angles as well. So for the exact same reason. Okay? Because they're corresponding angles as well. Now, in this proof, that was enough for us to say that triangle GIK is congruent to triangle HIJ. Which of the theorems or postulates that we mentioned earlier, right, will work for us? Remember, we're given so far we're having angle-angle similarity, we were given side-side-side similarity, and we were given side-angle-side similarity. So which of those three do you think would be enough for us to prove that those two triangles are congruent? Which of those three did we use? Yeah. Angle-angle similarity. Exactly. Okay. I'm sorry. Okay. And the reason why is because the only thing that we proved in here as far as congruent or proportional is all we did was prove that two sets of angles are congruent. That's really all we did so far. Okay. Let's look at number 9. Okay. Number 9, same thing. We're given that MQ is parallel to OP, and that's our given. Okay. And then the next statement says that angle QMN is going to be congruent to angle OPN. Okay. Why is that true? Why is that true? What reason would those two angles be congruent for? Yeah. Vertical angles, remember vertical angles are formed by two lines, and they're like essentially the opposite sets of them. So how about using the fact that these guys are parallel, right? And in fact, if you kind of just, I'm going to use purple here really quick. If I kind of just draw out these lines a little bit and realize what this is, this looks like a very familiar scene, right? What kind of angles are those? Anybody remember? This is one of the ones that I told you that we would use a lot. Anybody?
Alternate interior angles.
Perfect. There we go. Alternate interior angles. Okay. They're alternate interior angles. Now, our next reason, the next thing that we're going to do, and I'm going to kind of erase this again so I can. So this is what we have so far. Okay. Our next thing says something's happening because of vertical angles. Well, kind of like what Ben said earlier, we're going to deal with two angles being congruent because they're vertical angles. But what I want to know is which angles are going to be congruent. Angle what is congruent to angle what? Two angles are going to be congruent. Ashley, what do you think?
Angle N and P, but like OPN.
So OPN. So this angle right here is going to be congruent to which one? QMN. Okay, so we already have those. So QMN and OPN are already congruent by alternate interior angles. So what two angles are going to be congruent by vertical angles? Remember, vertical right? Vertical said that these two angles were vertical angles and therefore congruent, as well as these two angles were congruent. Yes? Perfect. Angle MNQ and ONP. Those two are vertical angles. So MNQ, Q and O, and oops, sorry. ONP. And again, we use the same three letters, and I know when you're looking at those two statements, a lot of you guys kind of see, hey, those are the exact same thing. All right, but if you look, right, the way that we write angles is very crucial. Okay? MNQ is a lot different than NMQ. So remember that middle letter that we use, that's the vertex of my angle. Right, that's essentially where my angle is actually taking place. Okay, so if we look at these two statements, in number 2, M is the middle of this one, and P is the middle of this one. So basically, this is the same thing as saying M and P are congruent. Right? This one, N is the middle, N is also the middle. Okay, so again, that's kind of why we have to use those three identifiers as markers. Okay, so now, which of the theorems that we've talked about is enough to say that triangle GIK is similar to triangle HIJ?
I think you wrote that wrong, by the way.
What's that?
I think you wrote it wrong.
Did I write it wrong?
Yeah, because there's not GIK or HIJ.
Wait, say it again?
There's not GIK or HIJ for that.
Oh, yeah, it is wrong. Sorry, thank you. You're correct. It should be triangle MNQ is similar to triangle PON. Why? Which are the reasons? We have again angle similarity, side similarity, or side similarity. Which of those three did we use? Well, just look at our statements. Do we have any sides proportional? Yeah. Angle similarity, right? Because we didn't prove any sides were proportional at all. If I look at my statements, this one requires AA requires 2 angles, SSS requires 3 sides to be proportional, and SAS requires 1 set of angles to be congruent, but 2 set of sides to be proportional. Okay? All right. So I'm gonna spare us. Now we'll do. Yeah. I'm gonna spare us because we kind of basically just did these. But if you want to try on your own, right? I will be when I post this, I will actually be posting the solutions to these 2 proofs. Okay. But this is just something that you guys can. And normally, if we were in class, I would have the class do this. But obviously, we want to make sure we get to the assignment and. It's a little bit difficult, so what I'm going to do is I'm going to allow you guys to, if you're on your own, to work through this, and then I will be, when I post this, this picture of the whiteboard, I will be posting it with the solution so you can check your work, okay? All right. Last thing I want to go through is just doing some algebra, which was here. So we're just going to kind of look at some examples of other types of ways that we can do this problem. So what we're going to do is we're going to state whether these triangles are similar, right? And if they are, right, we're going to complete the similarity statement, and we're going to tell which of the 3 theorems that or 3 postulates or theorems we used. Remember, the how you know, right, is, well, I don't know why it did green, but let's just do it. How you know, remember we have angle similarity, side similarity, or side similarity. Okay? So let's do number 1. Okay? Are these triangles in fact similar? Give me a thumbs up if you think yes. Give me a thumbs down if you think no. Nobody on Zoom. Okay. Got a couple thumbs up, but why do you think no, Ben?
Because they just don't. I don't know. They just don't like. Well, I just looked at the numbers, you know,
Mm-hmm.
and the numbers aren't like. You can't like. So I don't know how to explain it, but like you can't get to like from 10, you can't get to 18.
Right.
Like if you like multiplied it.
Okay.
And then I just put that together. Like you can't like multiply like 12 to get to 15.
Right.
Something like that. You know what I mean?
No, I know exactly what you mean. Okay, but here I'm gonna offer a different perspective. So we're looking at triangle KLM. Okay, so again I'm gonna use 3 different colors here. I'm gonna use red, use blue, I'm gonna use green. And what I want to try and see, what I'm going to do is I'm actually going to try a bunch of different things here and see, okay, are these two guys, so if I'm looking at this triangle, right, so the red is obviously my biggest side, correct? So which is my biggest side in this second triangle? 16. So those two would kind of have to correspond, okay? 18 is my middle side. Which of these two is my middle side here? 10 or 12?
12. Yeah.
12. Okay. And then 15 is my smallest side, and 10 is my smallest side. So if I'm looking at these two triangles, right, what I want to do is I want to compare those ratios. And how I'm going to do that is I'm going to go, well, that means I need to compare the ratio of, let's say, KL over FG, which needs to equal the ratio between I did KL, so FH over, sorry, no, that was wrong, Mr. Kiefer. Ratio of KM over FH, which needs to equal the ratio between LM over HG. So I need to check and see if those work. So now I'm going to plug in the values that I know. Well, KL is 24, FH is, or FG is 16. Does that equal the ratio between KM, which is 18, over FH, which is 12? Does that equal the ratio between LM, which is 15, over HG, which is 10? So what I need to do now is I just need to simplify each of these, okay? 24 over 16, what does that simplify to? Yeah. 3 over 2. Because they're both divisible by 8, okay? Now I need to check, does 18 over 12 simplify to that as well? Yeah, they're both divisible by 6, right? So it would be 3 over 2. And then does 15 over 10 also reduce to 3 over 2? Yes, it does. Okay? So what we've just essentially shown is that all 3 sides are proportional. Okay? So yes, in this case, right, we do have similar triangles. And in fact, KLM, so KLM, right, is going to be similar to FGH. And why did I do FGH? Because, remember, KL and FG, KM and FH, LM and GH. Okay? Those are the sides that corresponded. Okay. Now, which of our reasons allows us to say this? Angle-angle similarity, side-side-side similarity, or side-angle-side similarity? Which of those 3? Those of you on Zoom, you can put it in the chat box or you can go ahead and say it. Which of the 3 did we just use? Side-side-side similarity. Okay. And so that's kind of how we can do these types of problems. Okay. So again, I'm going to pose that same kind of idea. When you're kind of going back through watching this video, I want you to look at these other 3 right? These other three problems, and tell me. Actually, you can do the other two. I want us to look at number 4 together really quick. Okay? So I have 89 degrees and 87 degrees here. So those two angles aren't congruent, right? Does that mean that these two triangles are similar or not similar? Because I do have a set of angles in here that is congruent. Angle C is congruent to itself, right? So then the question is, well, these two aren't congruent, but maybe something like this is happening? We don't know, right? What do you guys think? Can these two triangles be similar? No, we don't have enough information. Okay? In this case, we just don't have enough information because, yes, we have that this angle is congruent to itself, but we have no idea what its angle measurement is, right? Because if this is the only way that these two guys can be congruent, or sorry, not congruent, similar, is if this somehow magically equaled 87 and this one somehow magically equaled 89. That's the only way that it could happen. But we don't know that that's the case because we don't know what this angle measure is. So we cannot assume that. Okay? So in this case, we don't have enough information. They may or may not be similar, but without that information, we can actually say that they're not similar. Okay? And then the last problem I wanted to go through with you, I'm sorry, I had 2. Oh yeah. The last problem I want to go through with you is, actually I'll do number 5 and number 7 with you. There we go. Okay. So for number 5, okay, and again, I always like to use colors. We know that triangle H, we're trying to find the missing lengths, and we already know that they're similar, okay? So again, I'm going to say, well, that means that HG and HM, right, if they're similar, that's exactly what that means. That means HG to HM is going to equal the ratio between GF and MN, which is going to equal the ratio between HF and HN. Okay, and again, I'm going to go ahead and color them to kind of see. So HF is right here. Okay, HN is right here. HG is here. And HM is here. CF or GF and MN. Okay. So which of these ratios do we kind of really need to check out? We're trying to find the missing length. How can I set up something? First thing I would do is plug in what we know. Okay? So, do we know what the length of HG is?
Yeah.
What is it?
24.
It's 24. Okay? So this would be 24. Do we know what the length of HM is?
18.
It's 18. Right, do we know what the length of GF is? Nope. Do we know what the length of MN is? Nope. And then HF, right? That's the one that's in question. That's the one that we're being asked to find. Okay? And then at HN, which is 21. So if I'm looking at these ratios, right, or at this proportion, please know that this one I'm not even going to use. It's not going to tell me any other information. And just because I don't have that middle one does not mean that I can't now set this up. 24 over 18 is equal to question mark over, equal to question mark over 21. Okay? So how am I going to solve this? First thing I would do, right, is simplify the left-hand side because I can. 24 over 18 reduces, right? They're both divisible by what?
6.
6, okay? So I can reduce this to 4 over 3 is equal to question mark over 21. Now how do I solve it from here? 21 divided by 3. How'd you come up with that? Why 7? Okay. So I'm going to teach kind of the way that that like kind of really helps you. Like, I know that you're explaining that and explaining it pretty well, but let me just kind of show you a little bit simpler kind of idea, right? So how we solve proportions, since I know some people had this question, is we do what's called the cross product property. Okay? And the cross product property, hopefully you guys remember from like algebra 1, I'm hoping. Right? All I do is I multiply the extremes by the means. Basically that's just saying is I take 4 times 21, right? And in order for this proportion to be true, that has to equal 3 times question mark. Okay. Now, you can go ahead and multiply 4 times 21 if you like. I'd rather not do that. I'm going to divide both sides by 3 first. And so I'm left with this 4 times 21 over 3 is equal to question mark. And then I can actually simplify 21 over 3, which is essentially equal to 4 times 7 is equal to question mark, which is 28. Okay. So I'm missing length here is 28. All right. And I was going to go ahead and do number 7. However, I want to get you guys going on your assignment for today. Okay? So please go ahead, and again, I will post the solutions for all of these by the end of the day, but please go ahead and begin working on your assignment. If you have any questions, please feel free to ask. I will be posting this video momentarily. Okay? And where is